Okay, in this problem we will find the x and the y-intercepts. So on your standardized exams, one of the main skills you'll need to do is you'll be given an equation in standard form like this: 3x minus 7y equals 21. Now this is standard form. Now the markers of something being in standard form is that you have a whole number integer value in front of both of the variables. So we'll call this a. The 3 is labeled a. The 7 is, or the negative 7, is labeled b. And then this whole number integer here on the other side of the equal sign is called c. So you end up with this standard form: ax plus by, in this case b is a negative number, equals c. And that's standard form. We'll call that standard form. And this is to contrast with slope-intercept form. The question is really, what is our goal? Okay, our goal with this problem is to rearrange the problem in such a way that it is in slope-intercept form, and then we could determine the slope, we could determine the y-intercept, and we could graph it. Okay, so there are a couple of shortcuts to find out what the x and y intercepts are, and I will show those. But first, let me show you the mechanics of rearranging this standard form equation into slope-intercept form. Our first step is to get y by itself. So we will subtract 3x from both sides of the equation. 3x minus 3x cancels, okay, or goes to 0, however you want to show it. This is 0. And then on the right side of the equation, 21 minus 3x, these are unlike terms. So we can't actually subtract 3 from 21 or anything. We just have to leave it as it is for now. So the process now is to rewrite what's left. We have negative 7y equals negative 3x plus 21. The reason I have rearranged these values on the right side of the equal sign is because the slope-intercept form of the equation, y equals mx plus b, wants that mx factor in front. Then you have the y-intercept. Okay? But this 21 is not the y-intercept, and we'll show you why. Because on the left side of the equation I still have a negative coefficient multiplied by the variable y. So in order to get rid of that, I divide out negative 7 on the left, and then the entire expression on the right side of the equal sign gets the same treatment. Divide the entire expression by negative 7. The negative 7's cancel on the left side of the equation, leaving y by itself, which is what we wanted. We wanted y by itself. Now we have a fraction on the right side. We have negative 3x plus 21 divided by negative 7. This notation can actually be rewritten in another way that allows us to complete the problem. What you have to do is realize that the negative 7 can be apportioned where it is beneath the negative 3x and beneath the 21. So we'll rewrite this again. Negative 3 over negative 7x, and then because there's a minus sign here, we can say minus 21 over 7. Now let's take a look. We have a negative and a negative for this x coefficient. This is the m factor. we have negative 3 divided by negative 7. We can eliminate those negative signs because a negative divided by a negative is a positive. So we can rewrite this yet again. Y equals 3/7 x minus 21 over 7. Okay, so this looks like it's in slope-intercept form, and it is. But we can actually go further and reduce these fractions. Okay, 3/7 cannot be reduced because both the numerator and the denominator are prime numbers. So we'll write y equals 3/7 x. But let's take a look at negative 21 over 7. 21 is not a prime number, and it can be divided by 7. So we could say, what is 21 divided by 7? And we find that it's 3. So I have y equals 3/7 x minus 3. Okay, now I claim we have the equation in slope-intercept form. And let's recall that slope-intercept form is y equals mx plus b. Okay, so what is our m? Our m, or our slope, equals 3/7. Okay, not 3/7 x, just 3/7. And that means that the rise is 3 and the run is 7. Rise over run. That means if I was going to graph this, I would start at the y-intercept, which is negative 3. Okay, so b, or y-int, equals negative 3. I would start there on the y-axis, and I would go up 3, and then I would move to the right 7 places on a piece of graph paper, and that would be my next point. And that's how you would actually graph this. So the state of the problem is we were asked to find the x and y intercepts. So we did find the y-intercept. The y-intercept is negative 3. But what about the x-intercept? Here's the question you have to ask. What is an x-intercept? Okay, that is where the line formed by the equation crosses the x-axis, just like the y-intercept is where the line formed by the equation crosses the y-axis. Now, let's focus on this for just a minute, and you'll see the trick that can be employed. In order to find the y-intercept, you have to ask yourself, what is y when x is 0? Because if we were to actually graph this, I'll just draw a quick graph. If we were to actually graph this, and this was 0, here's the y-axis, and here is the x-axis. If I were to graph this, and I know my y-intercept is negative 3, okay, let's go down 3 places and call this negative 3. We can use our rise over our run, and really we're doing this freehand, so it won't be exactly correct. 1, 2, 3, 4, 5, 6, 7. Okay, so here's 1, 2, 3, 4, 5, 6, 7. If I'm going to graph this line, I start at the y-intercept of negative 3, and then using my rise over run for my slope, which is 3/7, I go up 3, okay, 1, 2, 3, and then I go over 7, 1, 2, 3, 4, 5, 6, 7. Okay, so right there, visually, we have identified the x-intercept. We think, we'll put an equal sign with a question mark over it, we think the y-int is x equals 7. So let's connect those two dots, and you'll see the line. Okay, that's the equation of my line. Y equals 3/7 x minus 3. That is that line graphed. But how do we know for sure what the x-intercept is? Well, the way we know for sure is in order to find the y-intercept, we ask ourselves, what is y when x is 0? See, this is the x-axis. Right here, x is 7. But over here, where we find the y-intercept, x is equal to 0. So actually the coordinates for this y-intercept are 0, -3. So let's see if we can't find that using a bit of a shortcut. Let us assume, in our standard form equation, let us assume that x equals 0. Okay, let's draw that out. Remember, our standard form equation was 3x minus 7y equals 21. So this is kind of the shortcut. Your problem may ask you for more information than can be gathered using this shortcut, but maybe not. So what we're going to do is everywhere we see an x, we're going to put a 0. So I'll rewrite this. 3, open paren, 0 for that x, close paren, minus 7y equals 21. And let's see if it works out. Now 3 times 0 is 0. So that cancels out, which leaves us -7y equals 21. Well, again, we have to get y by itself to find out what y equals when x is 0. So again, divide out on both sides the -7. And what we end up with, this -7's cancel out on the left, we end up with y equals -21/7. Well, we already did that reduction in the previous iteration of this problem. -21 divided by 7 is equal to -3. So what that proves is that when x is 0, y is -3. Question is, can we do this same kind of analysis to find the x-intercept? Now let's look at the x-intercept. Okay, here's the y-axis. Y is 0 over here where this crosses the x-axis. So we have to ask ourselves, what is x when y is 0? Okay, so what we'll do is we'll go back to our standard equation, 3x minus 7. This time my red pen, I'll do an open parentheses and put a 0 in for the y, close paren, equals 21. Okay, just like the previous problem, this -7 times 0, that just cancels, and I'm left with 3x equals 21. All right, so we're really close. We're one step away from finding the x-intercept algebraically. So what I'll do is divide 3x by 3 and 21 by 3. So 3x by 3 and 21 by 3. The 3's cancel out on the left side, leaving me with x by itself. So now I have x equals 21 divided by 3. Well, what is 21 divided by 3? 21 divided by 3 is just 7. So x equals 7. So now we have found, using two different methods, all right, graphing it, putting it in this slope-intercept form, and also just plugging zeros in the standard form, we have found both our x-intercept, this is x-int, and our y-intercept, or y-int, which is also called b. And that is the full solution to the problem.